The rules of the competition are that you have to create a vehicle that can autonomously go around a track once, go left or right depending on the traffic signal, and take a U-turn at the last round based on the color of the last traffic sign.
For the WRO Future Engineers robot, the arena that we have created, we created it ourselves so that it is easier for us to test the bot ourselves. So the arena is 11 by 11 feet and the inside has to be completely black, painted black. So we started off by buying pre-cut wood pieces and we sanded them down and painted them.
The arena is 11 feet by 11 feet. So therefore we try to make it detachable to be able to store it. So we used pipes which we can connect and we label the pipes to each of the corners. So therefore it will be easy for us to detach it and connect it whenever we need to.
We will be using OpenCV and LiDAR in order to detect the various obstacles and autonomously control our car. This is the basic code for object detection using OpenCV. It detects red and green objects and highlights them based on which region is the largest. It outputs either red or green, which can be used to control the movement of the robot.
This is the app we are using to currently control our prototype robot for WRO. So here there's the connect to Bluetooth option, there's a forward, back and stop button. This is used to control the steering of the robot and this is used to center the steering of the robot. So in order to send the inputs, we are using different values for each of the inputs and we are using Bluetooth client to send them all to the bot.
We designed the body of this vehicle in Fusion 360 and laser-cut it using acrylic. We designed a casing for the battery also using Fusion 360. This is the design made in Fusion 360. It involves two parts, a main chassis for the robot, which was laser cut, as well as a casing for the battery, which is 3D printed. This chassis was designed with a 180-degree servo in mind in order to control the steering. This is the steering mechanism. It was 3D printed with three separate moving parts. One main bar that is connected to the servo motor, which is used to control the movement. The components we'll be using are a Raspberry Pi, N20 motors, and a 180-degree servo motor to control the steering, as well as a motor driver in order to control the movement of the motor. We designed a robot using an ESP32 controller, as well as an app designed by MIT App Inventor in order to control the robot, so that we can test the basic movement and function of the robot without relying on autonomous control.